Hello, this is the video for 165 and 166. So let's do it. 165 talks about randomization. So that's part of a design question. And we must build into our design randomizing. And this comes up all the time. We need to randomize. Was it random? Was the sample random? So let's read what type of a question they're asking. Randomization is an important characteristic of a well-designed experiment. So when I'm doing an experiment, I have to build in randomizing in order to eliminate bias. Okay, so this makes a lot of sense. I think we do this anyway. We've been taught to do this. So if I wanted to do an experiment, let's say with my period 2 class, and let's say I had 3 different treatments, treatment 1, treatment 2, treatment 3. So this could be one treatment, this could be another treatment, and this could be no treatment at all. But notice how that's how I'm wanting to design my study, and so that after the fact, I can compare the results of the 3 treatments. So we don't talk about this a lot, but could I design an experiment that didn't randomize, and then what would I end up getting? So I think that's what this question's asking is, what do I eliminate by randomizing? Or in another way, if I didn't randomize, what would be the outcome? So if I think about that, let's say I'm experimenting with my period 2 class, and I just took the first 5 people that walked in class and stuck them in there, and then the second group of 5 stuck them in there, and whoever came in last, that'd be my last group of 5. And let's say there was just 15 kids in that class. Notice this is where I'm supposed to be randomizing, and I didn't. So what do I eliminate by randomizing? Well, notice what happens here is that treatment 1 only gets in the early birds. And there might be something about people that show up early to places that might either systematically help them or hurt them, depending on what it is I'm trying to experiment. And the same thing here, the kids that show up last are all gonna only get treatment 3. And so when I compare results, I can't really figure out if it's really the treatment that I gave or is it really their habits. So if I would have randomized right here, so let me write that. If I would have randomized, then I would have eliminated a source of bias here. And that would be B. Certain groups from the population were systematically excluded. So if you think about it this way, systematically, because I did not randomize, I created a system in which all the early birds got 1, and the people that showed up late were excluded from being even able to do treatment 1. And we don't want to do that. So that's why we randomize our experiments. So notice by randomizing, getting all 15 kids an equal chance of being chosen for each of these groups, we want to do that. And so this would be what gets eliminated by randomizing is certain groups from a population here would systematically be excluded from data, and by randomizing, we would eliminate that type of a bias. Now let's take a look at this second question. It says a spinner on a full circle can take any decimal. So this is called almost like a clock or a timer. It goes all the way around to 400. And what's interesting here, so let's zoom in on our little timer. It can take any value, including a decimal value, between these 2 numbers. So this makes this question a little hard, but it does seem like if these were seconds, the amount of time it would take to go all the way around would be 400 seconds. So I'm going to just kind of guess and say that I think if I'm doing a probabilities problem, I'm going to put that out of 400. Okay? Now it says, what is the probability that the spinner would land between 175 and 225? So the spinner, this would be 200, and this would be 100. That's 300. And the spinner, we can imagine that this needle on the spinner could somehow figure out if it landed just a little bit in front of 100 would be 100.00001. We believe that this spinner can give me a decimal value. So now I'm trying to calculate the distance, I messed up there, sorry about that, between 175 and 225. Okay, so that would be 175 would be like a quarter right here, right? And then 225, so somewhere here. 225, 175. If I had to calculate this, it could be any value from 0 to 400 and between these two values. So between there is about 50, right? Between there, 225 minus 175, 0, 5. So if we think of those as tiny little slivers, there's 50 tiny little slivers that are 50 tiny little slivers that are numbers ranging from 175.0001 going all the way up to 2.24.99999. Any number, even could be decimal, ranging between those numbers. When I do this fraction, I get 0.125, and I'm definitely going to pick A. Now, why this number doesn't come up exactly, I've kind of looked it up, and I can't find exactly why. Because they included the number 0, I thought, well, maybe I should put 401 down here. But then I thought for the same reason, you know, and it's kind of like these questions where you're like, if I'm counting the amount of time that went from 1 o'clock to 4 o'clock in the afternoon, I have to count on my fingers. 1 o'clock to 2 o'clock is 1 hour. 2 o'clock to 3 o'clock, another hour. 3 o'clock to 4 hour, another hour. So I could have just done 4 minus 1. So it's like, could I have just gone 400 minus 0? And the answer to your question here is, I'm not exactly sure. I do notice if I change this to 401, I get 0.1246, which technically would round to this. I'm just going to stop the question there. If I learn more about this question, I'll redo the recording. Thanks for joining us.